What's up, spacers? This is your specialist, the Space Technician. In this Space News Roundup, we'll look into Russia and China building their nuclear power plant on the moon, Japan's first commercial rocket blowing up after liftoff, and Crew-7's return to Earth's surface in a splash. Remember, strapping in is optional, but recommended. Russia announces lunar nuclear power plant along with China. Recently, Yuri Borisov, the head of Russia's space agency, Roscosmos, announced that Russia and China are seriously considering delivering and installing a nuclear power unit on the lunar surface between 2033 and 2035. This is a huge development in the world of space exploration, and it could have major implications for future lunar settlements. But why nuclear power? Well, as we've discussed in previous videos, the go-to energy source in space is usually solar power. However, lunar nights last a whopping 14 days, which means that solar panels alone won't be enough to sustain permanent installations on the moon. That's where nuclear power comes in. Russia and China's joint lunar exploration program is already well underway, with plans to build the International Lunar Research Station at the moon's south pole. Each country is supposed to send a half-dozen spacecraft to complete the facility. However, there are some concerns about Russia's ability to hold up their end of the bargain, given the recent failure of their Luna 25 mission and the overall state of their space industry. But let's assume everything goes according to plan. What would a lunar nuclear power plant look like? Well, Borisov didn't provide too many details, but he did say that one of Russia's main contributions would be their expertise in nuclear space energy. He also mentioned that they're developing a nuclear-powered spaceship, or space tugboat, designed to transport cargo and collect space debris in orbit. Now, I know what some of you might be thinking. Isn't launching nuclear material into space a bit risky? And you're not wrong to be concerned. However, Russia and China aren't the only ones pursuing this idea. NASA also has awarded contracts to several companies to investigate the feasibility of small nuclear reactors for lunar missions, with the goal of having a working reactor ready for launch by the early 2030s. According to NASA, these reactors would need to weigh under 6 metric tons and produce 40 kilowatts of electricity, which is enough to power about 33 homes back on Earth. They would also need to be able to run for a decade without any human intervention, which is no small feat. The UK Space Agency is also getting in on the action, having given engineering giants Rolls-Royce £2.9 million, or about $3.7 million, to research how nuclear power could help future manned moon bases. Rolls-Royce unveiled a concept model of a micronuclear reactor at the UK Space Conference last November, and they're hoping to have a working version ready to send to the moon by the early 2030s. So, what are the advantages of using nuclear power on the moon? Well, for starters, it would provide a reliable and consistent source of energy, regardless of the lunar day-night cycle. This would be crucial for supporting life support systems, scientific experiments, and other critical infrastructure. Nuclear power could also enable more extensive exploration and resource extraction on the moon. For example, there's been a lot of interest in mining the moon for rare earth elements and helium-3, which could be used in fusion reactors back on Earth. A reliable power source would be essential for these kinds of operations. Of course, there are also some significant challenges to overcome. One of the biggest is the issue of shielding. Any nuclear reactor on the moon would need to be heavily shielded to protect astronauts and equipment from radiation. This would add significant weight and complexity to the design. There's also the question of how to dispose of nuclear waste on the moon. We certainly don't want to leave radioactive material scattered across the lunar surface for future generations to deal with. One possible solution would be to bury the waste deep underground, but this would require extensive excavation and drilling. Despite these challenges, it's clear that nuclear power will play a significant role in the future of lunar exploration and settlement. With multiple space agencies and private companies pursuing this technology, we could see some exciting breakthroughs in the coming years. Japan's first commercial rocket fails liftoff. On March 13, 2024, Japan's first commercial rocket, the Kairos, exploded just seconds after liftoff. It's a setback for the Japanese space industry, but, as we'll discuss, it's not uncommon in the world of rocketry. First, some background. The Kairos rocket was developed by Space1, a Japanese company founded in 2018 by a consortium of big names like Canon Electronics, IHI Aerospace, and Shimizu Corporation. Their goal was to capture a piece of the booming small satellite launch market by offering space courier services with a rocket capable of putting payloads of up to 250 kilograms into low Earth orbit. Now, let's talk about the rocket itself. The Kairos is an 18-meter-tall, 4-stage rocket. The first 3 stages use solid propellant, while the 4th stage, called a post-boost stage, uses liquid propellant. Solid propellant rockets are simpler and more reliable than liquid propellant rockets, but they offer less control over the thrust. That's why many rockets, like the Kairos, use a mix of solid and liquid stages. So, what exactly happened on March 13th? Well, at 10:01 p.m. Eastern Time, the Kairos lifted off from Spaceport Kii on the tip of the Kii Peninsula in western Japan. But just 5 seconds into the flight, something went wrong. In the livestream, we could see a large cloud of smoke, a fire, and fragments of the rocket falling back to the launch pad. Thankfully, no one was hurt, and the fire was quickly extinguished. Space1's president, Masakazu Toyota, said that the rocket terminated the flight after judging that the achievement of its mission would be difficult. In other words, the rocket's automated flight termination system detected a problem and triggered the self-destruct mechanism. This is a safety feature designed to prevent the rocket from veering off course and potentially causing damage or injuring people. So, what could have caused the failure? Well, Space1 hasn't released many details yet, as they're still investigating, but there are a few possibilities. It could have been a problem with one of the solid rocket motors, like a crack in the casing or an issue with the propellant grain. It could have been a guidance or control system malfunction that caused the rocket to deviate from its intended path. Or it could have been something else entirely. We'll have to wait for the official investigation to conclude to know for sure. Now, it's important to remember that failures like this are not uncommon in the space industry, especially for new rockets. SpaceX's Falcon 1 rocket, for example, failed 3 times before finally reaching orbit on its 4th attempt. And Rocket Lab's Electron rocket, which is a direct competitor to the Kairos, also had a failure on its first flight. In fact, Toyota referenced Rocket Lab in a press conference saying, Rocket Lab 2 did not achieve its mission at the inaugural Electron flight, but it went on to launch 3 rockets in its 2nd year. We can't stop here. We need to compete with this company. And that's really the key takeaway here. Yes, this failure is a setback for Space1 and for Japan's commercial space ambitions. But it's not the end of the road. Space1 will investigate the cause of the failure, make the necessary changes, and try again. Because that's what you have to do in this industry. You have to be persistent, learn from your failures, and keep pushing forward. It's also worth noting that this failure comes at a time when Japan is really trying to boost its space capabilities. The government has promised comprehensive support for space startups, especially those working on technologies critical for national security. And just last month, the Japan Aerospace Exploration Agency, or JAXA, successfully launched its new H3 rocket, which is designed to be a cost-effective way to put satellites and probes into space. So, while the Kairos failure is disappointing, it's not indicative of the overall state of Japan's space program. There's a lot of exciting things happening, and a lot of reason to be optimistic about the future. NASA's Crew-7 splashes down back on Earth. After spending an incredible 199 days in space, the multinational crew, consisting of NASA astronaut Jasmine Moghbeli, European Space Agency astronaut Andrei Mogensen, Japanese Aerospace Exploratory Agency astronaut Satoshi Furukawa, and Roscosmos astronaut Konstantin Borisov made their triumphant return to Earth on March 12, 2024. The crew splashed down in the Gulf of Mexico off the coast of Pensacola, Florida at 5:47 a.m. Eastern, aboard the trusty Crew Dragon spacecraft Endurance. This marked the end of an epic 6-month mission to the ISS, which began with their launch back in August 2023. Now, let's geek out about the technical details of their return. The Endurance spacecraft underwent a normal re-entry process before making a picture-perfect splashdown. SpaceX recovery team wasted no time in getting the crew out of the capsule, with all 4 astronauts emerging less than an hour after splashdown. That's some seriously impressive efficiency. NASA's Commercial Crew Program Manager, Steve Stick, praised the SpaceX team for their outstanding work in recovering the Dragon capsule. He noted that they continue to improve with each mission. It probably helped that the weather conditions were ideal, with light winds and calm seas. I mean, who doesn't love a smooth splashdown, right? But here's the really cool part. The Endurance capsule has now spent a total of 534 days in space, which is more than any other crew-rated vehicle in history. This talk about a spacecraft with some serious endurance. SpaceX's Senior Director for Human Spaceflight Programs, Benji Reed, couldn't help but brag about this incredible achievement. Now, let's switch gears and talk about the Crew-8 mission, which launched just a week before Crew-7's return. NASA astronauts Matthew Dominic, Michael Barrett, and Jeanette Epps, along with Roscosmos astronaut Alexander Grebenkin, blasted off aboard another Crew Dragon spacecraft named Endeavour on March 3, 2024. The Falcon 9 rocket carrying Endeavour lifted off from the historic Launch Complex 39A at 10:53 p.m. Eastern, and the spacecraft successfully separated from the upper stage just 12 minutes later. Talk about a smooth launch. Interestingly, the launch was originally scheduled for March 1st, but had to be postponed due to some pesky weather conditions along the launch corridor. Better safe than sorry, right? During the final countdown, a minor issue with the spacecraft's side hatch seal caused a bit of a stir, but SpaceX engineers determined that it was within acceptable limits, and the launch proceeded without a hitch. Now, the Crew-8 mission is particularly special for a few reasons. First off, it's the first spaceflight for Dominic, Epps, and Grebenkin, while Barrett is making his 3rd trip to the ISS. But here's the really inspiring part. Jeanette Epps, the last member of the 2009 astronaut class to go to space, finally gets her chance to shine after being removed from a Soyuz mission back in 2018 for undisclosed reasons. Talk about perseverance. The Endeavour spacecraft, which is making its 5th flight, will spend the next 6 months docked to the ISS. And get this, SpaceX and NASA are even considering extending the spacecraft's certification to allow for up to 15 flights. That's some serious confidence in the Crew Dragon's capabilities. But wait, there's more. The return of Crew-7 means that there's now an open docking port on the ISS for the upcoming CRS-30 Cargo Dragon mission, set to launch later this month. And let's not forget about the highly anticipated first crewed flight of Boeing's CST-100 Starliner, scheduled for early May. It's an exciting time for human spaceflight, folks. SpaceX has a jam-packed schedule of crewed missions lined up for 2024, with up to 5 flights planned, including Crew-8, Crew-9, AX-4, and the Polaris Dawn mission. It's going to be a wild ride. And we'll be here to cover all the action for you. Hit that like button, subscribe to the channel, and ring the bell to get more space news roundups as we go into the final frontier. This is the Space Technician, signing off for now, and I'll see you, Space Cowboys, in the next one.